How a person interacts with their environment can provide rich, contextual information about their intents, needs, and actions that facilitates effective communication between individuals. This information is often missing when collaborators are spatially distributed and must communicate via traditional video conferencing systems. Augmented reality, or AR, has the potential to better leverage environmental information to facilitate distributed collaboration. However, while a variety of work has introduced innovative sharing techniques to create rich, distributed AR applications, such applications still remain difficult to create. In this work, we present XSpace, a toolkit for creating spatially aware AR applications for distributed collaboration. Through a review of prior work, we first identify 3 main methods for creating shared virtual spaces, each emphasizing a different concern to spatially align separate user environments. XSpace consists of 3 main components. First, XSpace's developer toolkit allows developers to add shared space configurations to existing AR applications. Second, XSpace's server provides an architecture for multiple AR devices to share environmental information. Finally, a set of visual design tools allows developers or designers to simulate space configurations on real or synthetic environmental meshes. One method for creating a shared AR space is to center physical objects as anchors or reference points for virtual content. To configure a pair of shared anchors in XSpace's interface, users first draw a bounding box around relevant portions of each environmental mesh. Next, users specify the orientation of each object in a separate panel. Finally, in the simulation panel, we can see that avatars and objects are then positioned relative to that anchor. Creating a shared virtual environment could also be done by giving the users the ability to have a direct perspective into another space. When users add a portal, it will initially appear in a default location in both meshes. Users can then edit the position and orientation of each portal using transform controls. After confirming the position, the portal appears in the simulation interface. Similarly, users can add and position a miniature version of another mesh inside a space. After confirming, the simulation panel shows updated avatar locations in relation to the miniature mesh. Finally, portions of other users' scanned meshes could be overlaid on top of the physical environment in order to create a shared space. Users can directly manipulate meshes in order to create an intersecting area. After drawing a bounding box around the area to be shared, the simulation view will then show the remote mesh being overlaid onto the local mesh. Objects are then placed relative to the mesh geometry. To illustrate the utility and versatility of XSpace, we select 3 common single-user XR applications to extend with XSpace to support multiple distributed users. Each application implements a different technique identified in our design space. Snowball Throw is a multiplayer AR game that we developed on HoloLens and web using XSpace. Upon opening the HoloLens application, users first scan the areas of their room that they wish to share. While the scan uploads, users then visit XSpace's interface to configure the space. Here, a user is specifying an intersecting region around this couch and coffee table. The remote mesh then appears overlaid on top of the physical space, and avatars move around relative to the mesh geometry. Users can throw snowball projectiles that collide with each other or objects in either environment. Office Space is a shared workspace application that we developed as a web simulation of AR. Here, shared anchors are used to link 2 tabletops. Users can then see the other avatar working contextually in their space, regardless of the remote space's furniture layout. Finally, Room Design is a collaborative furniture layout application that we developed as a web simulation of AR. After placing the miniature mesh, users can add furniture objects to the space and pass them into the miniature space in order to arrange furniture from a top-down view. Overall, in this work, we demonstrate the potential of further involving environmental context in distributed AR collaboration. XSpace is an important step towards creating more immersive and effective distributed collaborative AR experiences by leveraging users' local environments.